Hello. In this video I'm going to look at velocity graphs or velocity time graphs. I'm going to look at them in a way which is really designed for the new GCSE 9-to-1 system. And so what we want to be able to do is to mainly solve problems that will involve these types of graphs, and there are two particular types we're going to look at, and one of them will be where we're actually finding the areas under a curve. And we would need to do this for a velocity graph if we had a certain type of question. Now there aren't many questions on this, and this is something which has been partially brought down from A-level. So what I've done is I've taken one question and I've adapted it slightly to meet the needs of this video. So here we have an example of a velocity time graph. And in this example, we're told that a car is traveling between two sets of traffic lights, and we end up with this type of graph. Now, the previous graphs that most pupils will have seen is one which will involve a distance time graph. And in this case, if you found the gradient, you would then have your velocity. Now, in this case, because it's a velocity time graph, it doesn't operate in the same way. We can find the specific velocity of the car just by looking at a certain time along the axis. So if we want to know what the velocity was after 30 seconds, we can see that it was 12 meters per second. We would not have to do much work. So most of the questions that involve this, which are a bit more complex, involve finding either the acceleration for the vehicle at any given point, or finding the distance that the vehicle has traveled between 2 points. And so this video is going to focus on those two particular types of questions. So here we have one of the parts of the question, which was to calculate an estimate for the acceleration of the car after 10 seconds. So when looking at the graph, we need to find where 10 seconds was on our graph. And so after 10 seconds, we can see that it was traveling at a velocity of about 9 meters per second. But because the question is asking for acceleration, what we would need to do is to calculate the gradient at this point, and we'd need to draw on a tangent. Now the reason the question says an estimate for the acceleration is because the tangents can be slightly out. But it's very important when answering this type of question you draw the tangent on the actual graph you're given, because the examiners will be looking at that to see how you got your gradient. From there, you would follow the standard process for getting the gradient of a line. You'd choose 2 points, and you would consider how far the graph has changed horizontally and vertically. So in this case, to get from left to right, it was about 13 seconds along the x-axis, and on the velocity, it's changed by 9 meters per second. Now to get our acceleration, we'd use a formula where it's the change in velocity, which is the change in y, divided by the change in time, our change in x. And so this would then give us a final answer, when rounded, of 0.69 meters per second squared. Now the actual answer could be about this, it could vary. The question didn't give me a specific rounding degree of accuracy to work to, so I had to create one myself. But one type of question that you could get on velocity time graphs is about acceleration. And this is where the gradient of that line is important. And what's increasingly likely to happen in the new GCSEs is that that is going to be of a curved line. It is not likely to be of a straight line. Now the next thing I'm going to look at is about how to estimate the distance traveled by the car. And in this case I've had to create a question for the previous graph where we're going to look at how far the car has traveled after 15 seconds. Now to get the distance traveled you need to find the area under the curve. But because it's curved you can't naturally do that. There's no easy way to do it. So what we need to do is to split that area under the curve into shapes that we can find the area of. And what we're typically going to use here is the trapezium. So using the x-axis as a guideline, I'm going to take every 5 seconds and draw a vertical line up to my graph. And then by kind of going approximately along the line of the graph, I'm going to create a series of shapes. Now, typically these will be sort of like trapezia, but in this case, the first one's a triangle. But if we were asked to say go between 5 and 20 seconds, then they would all be trapezia. So we would then want to find the area of each of these sections. And so I've labeled them up as T1, 2, and 3. And once we find the area of each little section, we'd add them all up at the end to find out our total distance covered. So since the first one's really a triangle, that's going to work out at 12.5 meters. The second one is going to work out at 36.25, and the final one is going to work out at 52.5. Now, when I was reading the values off the y-axis, they were a little bit of an estimate. It's not very accurate in this case. The one that you would have in an exam, you'd have to maybe demonstrate this a bit more, and you should be able to get a more accurate reading. But as long as you are clearly showing that, then you should be fine. And then if we add up these three values here, we have our estimate that the distance traveled was 101.25 meters. Now, what we do need to consider, and there have been questions or parts of questions on this, is whether that estimate is an overestimate or an underestimate. Now, if we do look closely, and it is a bit difficult here, there is a bit of a gap between the curve and the chord which has been drawn at the top there between the 2 points of those lines. And so what that means is that in this case it is an underestimate, because there's a little bit of area there between the trapezia and the graph which I haven't included. Now, if the graph was more like a quadratic and sloping upwards, then we would probably end up with an overestimate. Now, in certain curves, what would happen over time is that if there's a bit of a mix, then it will sort of balance out in the end. But in this case, just be aware that if you are creating any gaps or you're going over it, whether or not your estimate would be over or under the actual answer. Hopefully this video has helped out a bit with the idea about how to use a velocity time graph in order to get acceleration and distances. Thank you.